All right, welcome Algebra 2, Period 2, to this online lesson. All right, so this is going to be the next lesson, 10.5, and we're going to learn how to solve exponential equations. Now, there's going to be two kinds of exponential equations that we're going to learn how to solve. This first one is the easier of the two. We're going to just try to get the bases the same, and then we can set the exponents equal. All right, so if you look at number 1, 1, 2, and 3, you can kind of just use some common sense what x is going to equal. So we're trying to find out 2 to what power would equal 8. And so you can take your calculators out. You can start throwing some numbers in for the exponent, 2 to what power equals 8. And we should see that x equals 3. Let's do that. X equals 3. All right, so 2 to the third does equal 8. Then you could do number 2, 3 to what power equals 81. And so that's going to be 4. X equals 4. All right, and then 4 to what power equals 16, and so we can see x equals 2. All right, so in order to solve exponential equations, you want to get the bases to be the same. Get the bases the same. All right, and so there's a property that says if b to the x power equals b to the y power, if the bases are the same, so again, these are our bases that we're looking at, bases. If those are the same, then the exponents must be equal to each other, right? X equals y. And so that's the concept that we're going to use. We're trying to getting the bases the same, then we can cancel them out and set the exponents equal. And then you just solve for x or whatever variables in the problem. All right, so let's go ahead and do number 4. So it says solve each exponential equation. And so we're going to drop the bases, set the exponents equal. All right, so on number 4, we can see both bases are already the same. They're both 6. Since they're the same, the property says you can cancel them out, set the exponents equal, and then just solve for x. All right, so we're going to get the x's on one side. All right, so we get 1 equals, and then that's x, and so x equals 1. All right, that's it. You could substitute that 1 back in for both x's and see if it actually works, and it will. You'll get 6 to the second power equals 6 to the second power. All right, so let's try 5. So both bases are the same. They're both 2, so we can cancel the bases out, set the exponents equal, and then we'll just solve for x. So here we have to add 4 over. We get x equals 7. All right, number 6. The bases are the same, so we can cancel them out. Set the exponents equal. 4x plus 2 equals 22. And here we'll subtract the 2 over. We get 4x equals 20, and then divide by 4. We want to simplify our fraction, so x equals 5. All right, number 7. Both bases are the same. So we can cancel the 3's out. Set the exponents equal. All right, and then we'll get the x's on one side, subtract the x over. Then I will subtract 6 over. And so negative 11 is equal to x. All right. So most of this is just algebra 1, solving an equation. We're just trying to get the bases to be the same so we can use the property, cancel the bases out. All right. So now in number 8, the bases are not the same. We have a 3 and a 27. And so the idea is to get them to be the same. Now you want to think big base numbers can go smaller using exponents. Okay, big numbers can go smaller. Small numbers cannot go bigger. All right. So the first thing you do is to find your bigger number. So in this case, 27 is the bigger base. See if you can make it the same as the other one, the smaller one. Well, 27 we can make it a 3. We just use exponents to do that. All right. So the left side is just going to stay the same. The right side, 27, we're going to change it. Okay, and we need it to be 3 to some power. Well, if you use a calculator, you'll see it's 3 to the third power. All right, it still has a value of 27, but we're just changing the look of it. And by doing this, we're allowed to cancel the bases out now, and now we can just solve for x. So x plus 4 is equal to 3, and now we subtract the 4 over, and we get x equals negative 1. All right. So this would be a more difficult problem if we were just going to guess and check to throw numbers in. Okay, so we want to use the concept, get the bases the same so you can cancel them out. All right, so number 9, we have a base 32 and a base 2. So again, try to get the big number to be the same as the smaller one. All right, so 32, we're going to change it to a 2. All right, so you take your calculator and you figure out, well, 2 to what power is the same as 32? All right, so you just start throwing numbers in, and it's going to be 2 to the 4th, that's 16 to the 5th. All right, and then we have the x plus 3 equals 2 to the 2x. All right, so now we're going to take this 5 and we can distribute, because it's a binomial, that 5 has to get distributed to both x and the 3. So now we have 2 to the 5x plus 15 equals 2 to the 2x. Now the bases are the same, and we can cancel them out. And now we just solve for x. All right, so 5x plus 15 equals 2x. I'm going to subtract the 5x over. So 15 equals negative 3x. Divide by negative 3, and so x equals negative 5. All right, number 10. I have a base 8 and a base 4. So again, we will try to get the bigger one to be the same as the smaller one. So 8. We want to try, can we make it 4 to a power? So we check 4 to the first. No. 4 to the second. No, because that's 16. All right, so we can't make it 4. So what we do then is to make both of them a smaller number. So we go smaller than 4. And so we want to make them both 2. All right, so 2s are going to work a lot, 3s are going to work a lot. So kind of look for those numbers if you can't figure out what it is. So try to think 2. All right, so 8 is the same as 2 to the 3rd power. That's raised to negative 2x. And 4 is the same as 2 to the 2nd power. See, they're both 8 and 4, they just look different. All right, so now we're going to go ahead and multiply those exponents together. So 2 to the negative 6x equals 2 to the 2nd. And now the bases are the same. Cancel them out. Set the exponents equal. All right, now we'll just get x by itself. We can divide by negative 6. We'll simplify this fraction down. All right, so sometimes you have to make both of them a different number. And you want to go smaller. All right, so this one when we have a fraction. So the first step is get rid of the fraction by flipping. All right, so we're going to keep this left side for now. And 1 over 8, if you flip it, it becomes 8, but now it becomes a negative 1 exponent. All right, so anytime you have a fraction and you flip it, do the reciprocal, you have to put a negative 1 exponent. All right, so now we can make both of them base 8. 64 is the same as 8 to the 2nd power. All right, to the x minus 4, and then we have 8 to the negative 1 to the x, and now we have to multiply our exponents, so we have to remember to distribute the 2, and then we're going to multiply the negative 1 and the x together. So 2x minus 8, and then 8 to the negative 1x. All right, so now we'll cancel the bases out. Set the exponents equal, and solve for x. All right, so here I'll subtract 2x over. Negative 8 equals negative 3x, and then I'll divide by negative 3, so I get x equals positive 8/3. All right, so anytime you have a fraction, flip it, make it a negative 1 exponent. Then try to get the bases the same. All right, so let's try number 12. So 12 is just asking us what base could both of them be made to be the same as. So this helps us with solving exponential equations where the bases are not already the same. All right, so let's go ahead and practice. So we have a base 3 and a base 9. So remember, big bases can be made smaller. All right, so 9, we could change it to base 3. That's the same as 3 squared. All right, so that's the same as 3 squared. So we would use base 3 for both of them. All right, number, or B, so we have a 4 and an 8. So 8, we would try to see could we make it a 4. No, because 4 the first, no. 4 the second, no. 4 the third, no. So then you got to make them both smaller. All right, so 4 we could change to 2 squared. 8 we could change to 2 to the third. So base 2 would be the one we would want to use. All right, C, 27 and 9. So we want to change, look and see, can we change 27 to a 9? 9 to the first? No. 9 to the second? No. 9 to the third? No. So 9 isn't the base we could use, so we go smaller. Well, we can use base 3, because 27 is 3 to the third, and 9 is 3 to the second. So base 3 is the one we would want to use. All right, and then D, 1/10 and 100. So again, when we have a fraction, you want to think flipping it first, and look at that first. All right, so now it's 10 to the negative 1, and 100 is what we're looking at. And we can make them both base 10s, all right? Because 100 is 10 to the second power. And so we both have base 10s on both of them, so 10 is the base that we would want to use. All right, so then these bottom 8 problems are just review of simplifying logs. All right, so go ahead and try and see if you can simplify each of those, and then I'll put the answers down. All right, so those are the answers. All right, so I think that's it for this lesson. And go ahead and try the problems on the homework and check your answers. If you have any questions, send me an email and I'll see if I can walk you through it. All right, thank you. Have a good day.